It's above you, below you, and all around you. It's colorless, invisible, odorless, and yet essential to our function. But underwater, it can be more dangerous to divers than sharks. But it's also what makes that pint of the black stuff so creamy and delicious. So what is it? Element number 7 on the periodic table, the 5th most abundant element in all the Earth, and 78% of our atmospheric air, I give you nitrogen. Nitrogen was found and discovered in 1772 by Daniel Rutherford. He took some air, took away the carbon dioxide, took away the oxygen, and found that all that's left over can't sustain life or combustion. So his friends over in France a few years later, Lavoisier, called it azote in French, which means lifeless. Now, even though nitrogen can't support life on its own, it sure can support the life of the pub on a Saturday night. So, nitrogenation of beer started in 1959 by Michael Robert Ash. He started incorporating nitrogen into beer because it's not a natural product of the brewing process. So these tiny, tiny bubbles end up in our beer when the nitrogen gets forced through it. And when you pour a pint, you end up with 300 million bubbles of nitrogen in the pint glass. But what's the deal with that cascading effect? I mean, do bubbles actually fall down? Are we defying the laws of physics? Not exactly. So what happens when your beer is poured is the nitrogen and the liquid are together in a two-phase mixture. And computational fluid dynamics and high-speed cameras have helped us understand this phenomenon, whereby the liquid is going down inside the glass and the bubbles are floating up at the same time. But nitrogen bubbles are 10 times smaller than the carbon dioxide bubbles you see shooting up in a champagne glass. So that's why they have a smaller buoyant force. So we see the bubbles are falling down in the glass, but really they're pushing up against the liquid while falling with the liquid. It's like a guy running up an escalator. When we look far away, he's not actually moving, but it's not until the escalator stops that he's allowed to come to the top, just like our nitrogen bubbles come to rest on the surface. So, can we make this process go any faster? Unfortunately, not really. Some researchers in Limerick and Oxford said that if we put the beer in a really weird-shaped cocktail glass, then it'll be a lot faster. But I'm not sure the world is ready for that. So, next time you're watching the rugby, having a pint with your friends, I dare you to say nitro instead of sláinte, because you could end up having a gas conversation.